today's topic is on concentration. So this is the first time we're actually going to look at doing some calculations that we can actually also do in the lab. So this is a very important topic. It's going to stick with you for the rest of the unit, so make sure you pay attention to this one. So concentration, denoted capital C, is the ratio of the quantity of solute to the quantity of solvent in a solution. And we actually have many different ways of expressing concentration. So we're going to look at a couple less common ways, and then we'll look at the most common way that we use it in chemistry. So first off is percent concentrations. You've probably seen this on household products or foods, or maybe some household chemicals that you have. But it basically is a percent either volume by volume, volume by mass, or mass by mass. So here's an example right here. Percent volume by volume, or we look at it as percent V over V. We use that when the solute is a liquid and the solvent is a liquid as well. So in this case, we have the volume of a solvent, or the solute, sorry, and the solvent times 100%. That's how we calculate it. So, for example, vinegar is actually 5% acetic acid by volume. So that means if I have 100 mils of vinegar, I've actually got 5 mils of vinegar in 100 mils of water. Okay, so it's diluted to 5%. So that's what the percent means. And then we have a bunch of other different examples. Here's an example of a percent of mass by volume. So this is when we dissolve a solid into a liquid. Okay. So the example that I have here is 3.9 grams of Kool-Aid per every 2 liters or 2,000 milliliters. Or that is the same as saying about 0.2%. So again, what do we do to calculate this out? You would do 3.9, that's the top, your mass of the solute, so 3.9 grams, divided by, in this case, 2,000 milliliters. Okay, and that's how you would get your 0.20%. Okay. Oh, and sorry, you'd have to times it by 100 there. Okay, and then the last one, same thing, percent again, but it's mass by mass. Okay, so when your solute and your solvent are both measured using a mass, we use percent mass to mass. So an example is 140 grams of a gold necklace may contain 3 grams of gold, or about 2.1% gold. Okay, so that, again, how did I get that? Well, I took the gold that I have divided by the total mass of the necklace, grams, sorry. And 3.0 grams, okay? And again, times 100, okay? And that would equal about 2.1%. So those are, it's the same calculation over and over and over again, where you take the solute over the total solvent and you multiply it by 100 and you get a percent, okay? The mass to mass, or the mass by volume, or volume by volume, just depends on what you're dealing with. So if we're dealing with water, we can measure water in milliliters. If we're dealing with, say, gold, we have to measure gold in grams. So depending on what you're dealing with, you're going to pick a different one of these. But I just wanted you to be familiar with all of them. Okay, the next one is parts per. So this is useful for very, very, very dilute solutions. It's used a lot in biology and environmental sciences, so we're not going to see too much of it now. So the 3 ones that are used are parts per million, parts per billion, or parts per trillion. So if you're looking at, say, 1 part per million, that's about a drop of something dissolved in a bathtub full of water. So it's still a very, very small concentration. Parts per billion would be a drop of something dissolved in a swimming pool. Again, a very, very small concentration. And parts per trillion would be a drop in a small lake. So very, very small concentrations, which is why we don't use them too often in chemistry. How would you calculate any of these? It's the same as your percent formula. So you would do basically the amount of your solute divided by the total of your solution or your solvent. Okay, but instead of timesing by 100 to get a percent, you would times by 10 to the 6 for a million, or you would times it by 10 to the 9 for a billion, or you would times it by 10 to the 12 for a trillion. So it's the exact same calculation as I showed you on the last slide, but it will it will depend on what I'm asking you for, okay? You really won't see too many examples of this. If you see a question like this on a test or on an exam, it'll be in a multiple choice. So as long as you understand how to sort of figure out this formula, you should be good. All right, here's the most common one we're going to do in chemistry, and that's molar concentration or molarity. The molar concentration is the number of moles of solute, that's N, per liter, L, or volume of solvent, okay? So here is our new fancy-dancy formula. C equals N over V, where N is the number of moles, V is the volume, and C is the concentration or molarity in moles per liter. The other unit you will see often is just a capital M, and when you see capital M, we say molar, like a tooth. So I might have like a 0.2 molar solution. That's the same as me saying it's a 0.2 mole per liter solution. All right, so let's try some calculations now. So, first example, what would be the concentration of a saline solution where you have 3.5 grams of sodium chloride dissolved in 1.5 liters of water? So, I'm asking you to find concentration, that's C. I'm giving you a mass, and I'm giving you a volume. If you look back in your notes, you know that concentration is moles over volume. So my first step, I'm going to have to find the number of moles of NaCl, given the fact that I have 3.5 grams. So again, what will I do? I'm going to divide by the molar mass of NaCl. So if I do that out on my calculator, I get 58.44 grams. So I'm going to divide 3.5 by the molar mass, and I'm going to get 0.05989 ... moles of NaCl. Awesome. So now I've got moles of NaCl, check. I've got volume of NaCl, check. I can plug it into that equation and find the concentration. So my concentration will be 0.05989 moles, and my volume in this case was 1.50 liters. So I divide the two, and I get 0.0399269 moles per liter, or capital M, molar. And now I'm going to round to my significant digits, which in this case is 2. So I have 0.040, capital M, or you could also write moles per liter. So that's how you do a concentration calculation. So let's try one more. How many grams of NaOH are required to make 75 mils of a 1.75 molar solution? So again, figure out what's given to you in the question. I'm asking you for how many grams. That's the mass, okay? I've given you a volume, and I've given you a concentration. You have to find mass. So again, let's kind of work our way backwards. We know concentration is moles over volume. Well, I have concentration and I have volume, so I should be able to really easily find the moles. And then from our last unit, everybody knows how to convert from moles to mass using the molar mass. So this should be pretty straightforward. So our first step here is going to be to find the number of moles of NaOH, given the fact that I have C equals N over V. So if I isolate and rewrite my equation, okay, if I multiply both sides by V, I get C times V equals N. So that's what I'm going to plug in down here. So the number of moles of NaOH is going to be the concentration times the volume. So in this case, my concentration is 1.75 molar, or moles per liter. And I'm going to multiply that by I'm going to multiply that by 75.0 milliliters. Now, do you see a problem with this if I try to cancel out my units? Have a look. I've got liters on the bottom here and milliliters here. Technically, those two units cannot cancel out because they're not the same unit. So what I've got to do is change either this one to milliliters, which is uncommon to do in chemistry, or I would change this one, change it to liters, okay? And that's one thing, that's why I gave you this example. You have to always, always convert your volumes to liters. So 75 mils is 0.075 liters, okay? All I did was divide it by 1,000, because I know that there's 1,000 mils in 1 liter. Okay, so that's how I get that part there. So now I have 1.75 times 0.075, and I get my answer there is 0.13125, and my units are now moles because my liters canceled out. Units are moles, that's what I write down here. So that's my moles of NaOH. Great. So now what do? Easy peasy, my question's asking you to find the number of grams. So if I have this many moles, it should be really easy for everybody to convert your number of moles to grams simply by multiplying by the molar mass. So in this case, if I have my molar mass of sodium hydroxide, it's 40.0 grams. I end up with 5.25 grams of NaOH. So what does that mean? That means, if I go back up to my question, if I take 5.25 grams of NaOH and I dump it into some water and make my final volume 75 mils, I will have exactly a 1.75 molar concentrated solution. Okay, this is my homeopathy rant. You have 2 more examples in your notes. I'm going to talk to you guys a little bit more about homeopathy in class because it's kind of a really cool area that I like to discuss. So that's it for now. If you would like to try the next 2 examples, we will take them up in class to make sure that everybody has the right answers. One is a really easy C equals N over V question, and then the others are using your percent calculations to figure out those. So see if you can try those and then bring them to class and see if you get the answers right.